This is a how-to video on using Do More Designers BRX PLC's JSON build instruction. It assumes you already are familiar with the JSON data format, or you have watched our training video on the JSON data format. The JSON build instruction does one of two things. It builds a single object with one or more name value pairs, or it builds a single array containing multiple values. To build an object, it assigns a value to a name, creating that name value pair. But it also allows you to add multiple rows of name value pairs, up to 50. If we double click on a row, or we use the Add or Insert buttons, we can pull up a dialog to add the name value pair. We'll talk about that Insert Structure Fields button in a moment. But first, the dialog. The first thing, of course, is that you must give your name value pair a name. This can be a static string contained in quotes, or a variable string like an SS, SL, or a user-created string element. Then you must assign this name a value. In keeping with JSON value types, the value can be a numeric, a Boolean, a string, another object, or an array. Yes, these are only 5 of the 6 value types available in JSON, the 6th being null. But if you'll notice the little comment in the dialog that says, a string element like SS0 or string literal like null, this will give you a clue that if you want to use null value type, then you will have to manually type it in double quotes right here in this box. And make sure the enclosed in quotes is not checked. If this is hard to remember, then you can always look down at the bottom of the dialog in the example box to see exactly what you're creating. Remember that the null value type should not be contained in quotes. The buttons at the bottom should be self-explanatory. Now let's talk about this Insert Structure Field button. It's another way to add several name value pairs at one time. Pressing this button pulls up this dialog. By default, the system structure $now or SDT0 is put there, but any structure can be used. But just as a demonstration, if I use the default, this will be the result. Notice that each useful structure member of SDT0 is made into a name value pair. So, ever how you populate the rows, or whether you only populate one row, the JSON build instruction will add the necessary formatting of curly braces and commas as needed. The second function JSON build allows is the building of an array of values. The difference here is that you cannot build multiple arrays, as it at first may seem since there's multiple rows allowed. Instead, the multiple rows are provided in case you have non-contiguous values to add to a single array. For example, you may want to add D10, D50, and then the range of D100 to 105. If so, you'd have 3 lines that look like this. 1 line for D10, 1 for D50, and 1 for the range of D100 to 105. When you add a row, this dialog comes up. Notice the name parameter is missing. That's because you're not making name value pairs, but merely an array of values. So you must choose the value type as a numeric, Boolean, string, object, or array, just as before, but there is an additional box added called Range of Array Elements. So, this is where you can define contiguous ranges of elements to include in your array. The JSON build instruction will add the necessary square brackets and commas for proper formatting. As a note, the Insert Structure Fields button, even though it is not grayed out, it doesn't make any sense to use here. The reason being that it creates name value pairs, not merely values. At the bottom of the JSON build is the JSON output record box. Regardless of whether you use the instruction to create an object or an array, you will here have to tell it where to place that newly created record. You have the choice of putting it in the standard elements of SS, SL, or your user-created string, or it can be stored in a numeric data block containing text. We'll see how that will be important later on. So how do we go about building a JSON record? Well, let's look at a simple example with a lot of data. Let's say we have an automation plant that has a particular building. In this building, there is an oven that has 3 heating zones in it. Each heating zone has 3 temperature zones of measurement. Let's say also that each zone measures the air pressure as well. Further, let's say it measures the humidity. Now that's quite a bit of information, but let's make it even more interesting. Instead of just one oven like this, let's say there are 3. And further, let's say there's an entire other building in this plant with an identical configuration. This indeed is a lot of information. But even so, we want to make this information available so that these processes could be monitored remotely. This example is a good candidate for using JSON data format simply because of its hierarchical arrangement. This should be very straightforward. In our minds, we are already thinking of this data in a hierarchy. In our example, there is a building, an oven, and a zone. And this oven zone has 3 temperature measurements. These 3 measurements could be put in an array that we'll just simply call temp. Why an array? Well, it doesn't have to be an array. We could just create temp 1, temp 2, and temp 3, but I chose an array just because it makes sense and also to demonstrate the JSONBuilds array function. At the same level, we add the pressure value and the humidity. Of course, these 5 values would then belong under zone 1, and this zone would belong under oven 1, and this oven would belong under building 1. See, that's not hard. And then, of course, zone 2 is added at the same level as zone 1, and then zone 3, so that we have 3 zones under the same oven. This same process would be repeated for oven 2 and oven 3. So the hierarchy is clear. Measurements of a zone in an oven in a building. Finally, we add the second building under building 2 as essentially a copy-paste version of building 1. But how do we use the JSON build instruction to do this? Well, now that we've arranged our data in a hierarchy, we must use the JSON build instructions in such a way as to build the data up from the lowest level. That's easy to see in our hierarchy because it is the data that is indented the most. So starting at that lowest level, we would use multiple JSON build instructions to build the temp array for each zone. So let's look at one oven. We build this array of values. Let's say in zone 1, the 3 temperature values come from R100 to R102. When the JSON build is executed, it will go and grab the current values stored there. The JSON build will then add the proper formatting required, commas and square brackets. We also tell the JSON build to store this formatted string in SS0, for example. Subsequently, we do the same for the other temperature arrays, storing them in SS1 and SS2. Now we move up a level. Here we see that humidity, pressure, and temperature, or temp, are all at the same level. The array we just created must become the value portion of a name-value pair, along with humidity and pressure, which each have a single value. Since the string is probably getting much larger than an SS can contain, we'll store these in SLs, like so. Moving up another level, shown in blue, we can now assign SL0 the name Zone 1 and SL1 Zone 2, etc. We'll store those in SL3. Remember, we have 2 more ovens with this same arrangement. Moving up another level, shown in red, we can now put this arrangement into Oven 1. And don't forget Oven 2 and Oven 3, even though they're not shown here. Since this structure is becoming very large, very quick, it would not be possible to store it even in an SL, which is only 256 characters long. So in anticipation of large strings, I create a block of strings where each string in that block is 1024 characters long. I called it JSON data. I would store each oven in subsequent JSON data locations, JSON data 0, 1, and 2, and so forth. But we still have yet another level, which is going to be even larger. We now move up to the building level, shown in purple. And there are 2 buildings. And by this time, I was sure that the record of data we are creating would be even longer than the 1024 characters. So what do we do now? Remember that JSON output record box? This is why that second option is available, called numeric data block containing text. So in the system configuration, or right here in the instruction itself using the create byte buffer button, I create a memory block made of 2048 elements. Each element in this block is merely 1 byte long. This allows me to store a single string of text that is up to 2048 characters or bytes long. I called this one JSON buff. Thus, JSON buff 0 would contain the first byte, JSON buff 1 would contain the second byte, and so on and so forth. This is where I will store the final huge record. Now let's just go to the ladder logic and do it. Okay, so here you can see I have a program already written called JSONBuild, and I'm going to execute that by turning on C0. So we got that guy running now. And here you can see we want to start with C2, this rung here. We want to put some values in R100 through 114 to simulate the temperature values and the pressure and the humidity. So if I execute that, you can see that this got filled up with some values. And then the next thing is we're going to start building our JSON data. So here in this one, if you remember, we're going to build the array first. So if I open this guy up, you can see an array. And we'll double click here, and you can see I give it the value R100 is numeric. This is the first value in the range. And there's going to be 3 values, R100 through R102. And this down here shows you an example of what it's going to look like. Once we get those values, then it's going to format them and then stuff them into SS0. Then the second one here is going to go up a level, and it's going to take that array that we just made in SS0 and assign it the name temp. And we're going to get R103 and assign it the name pressure, and R104 and assign it the name humidity. So here you can see, for example, the humidity. There's the name humidity, telling you where to get it from, an example of what it's going to look like. And also this one is going to give it, it's going to go get SS0, whatever's in there, which is what we just built as an array, and assign it the name temp. So since there are 3 zones, then we're going to have 3 rungs just like this. So if I turn on C3, you can see the data in SS0 is that array, and then SL0, which is this one over here, is going to have the humidity value, the pressure value, but you can't really see it that well. But there's this great tool in Do More Designer. You go over here to this little wrench and pick JSON Pretty, and see there we can see it very easily. Since I was on this instruction, the JSON Pretty automatically picks this output record string and stuffs it right there, shows you the raw string, and then you can see here now that the braces now contain the humidity, pressure, and temp with associated values, and also this array that's delineated by these square brackets. So we can close that out. And we can do the same thing with this rung, turning on C4, and go over here again, pick the JSON Pretty, and there you can see it is also the same with its values. Close that one out, and we'll do it for the third zone. So now you can go over here and see, scroll this guy up, and pick this tool, and look at SL2, and see that it got built properly too. You know, you could also look at the this one here. Doesn't matter which one. It's got this tool here. You pick this as a 2, so you can just see the array. The array by itself is there. Now next, what we're going to do, well, now we're going to go and assign each of these zones that we just created. We're going to assign them the name, Zone 1, Zone 2, and Zone 3. So if I go here to this guy, you can see that the field name is Zone 1 and get that data from SL0. So it's going to say Zone 1 is the contents of SL0, which we just built. We're going to do the same for Zone 1, Zone 2, and Zone 3. That's going to build those up and store them in SL3. So when we execute that with C6, it's going to get stuffed into SL3 as we told it to right there. Go over here and pull up the JSON Pretty for that one. And there you can see how we're building this up slowly. There's Zone 1 with all of its values, Zone 2 and Zone 3. And if I stretch that out, I can see that the whole thing is ready. Now that I have this object, well, that's going to go up another level. And the next level is going to be assigned to an oven, right? So remember we had 3 ovens, and each oven has 3 zones. Now I'm just going to pretend that we've already done this zone generation right here, the same build for the other 2 ovens. And so you can see here, I'm going to assign oven 1 with what's in SL3, which we just built, but also going to just duplicate it just for the sake of making this shorter. And we're going to say the same data we'll call oven 2 and the same data we'll call oven 3, when actually I would be getting these from different locations. But that's what we're going to do with this one, with the C7. And go up to this oven, and remember this one, if you'll notice, this one's going to build these up and stuff it into this JSON data 0 string, which, if you'll remember, was a string that is 1,024 characters long. So once we do that, then you can see it was actually 640 characters long, so that would never have fit into an SL, which is only 256. So it was a good thing we did that. But you can also go and see that it doesn't really matter with this tool. It knows what to do. So when I pick it, it goes and picks JSON data 0, shows me the raw data, and again arranges it in this nice pretty format. Now you can see it's pretty big now. We've got oven 1 with 3 zones, oven 2 with 3 zones, and oven 3 with 3 zones. So now we're going to go up to the building level. So we'll close that guy out. And here, remember, this one's already 640 characters long, so we're going to have another one that's another building. It's going to be about that long. And then we're going to stuff that into something. And if you remember, we talked about that. Again, I'm going to say that we've already done this for building 2. We're just going to use the same data for the sake of making this shorter. But here you can see I picked that numeric data block containing text. And JSON buff is the name of that byte buffer that I created, and I made it 2048 long. But this instruction also says tell me the length and stuff that value into D0. So that's all we're going to do. This will be our final one. So when I turn on C8, you can see it's 1,307 characters long. So now again, this nice little tool, I don't have to do anything. I just go print select this, and you can see here, instead of using string structure, it selected the numeric data containing text. It automatically selected that, selected the JSON buff, and it knows what number of bytes to display as D0, because D0 is going to change. You know, it's 1,307, but the next time I run this, it might be, 1,400 characters long or something. But again, now you can see our final structure has been completely built in the hierarchy we wanted. Here is the object itself. There's building 1 with 3 ovens, 3 zones each, and scrolling down here, there's building 2 with oven 1, 2, and 3 with their each 3 zones. So you can see this is a massive JSON data record that we just built up just by observing hierarchy. So that concludes how to use the JSON build instruction to build a JSON data record. Now the next video will tell you how to use the JSON parse instruction and how to actually extract data from such a structure as this. Thanks for watching.